Students, today we will be learning the position of different elements in the long form of periodic table, that is modern periodic table. As we all know that all the elements are arranged according to their increasing atomic number. Okay, so the elements having the least atomic number, that is hydrogen, is placed in group 1 and period 1. Can you see here group 1 is this group 1 and this is period 1. So in this period all those elements are kept which are having only K shell in them. So first element is hydrogen having atomic number 1. So that's why its valency is 1. That means it has 1 electron in its outermost orbit. So that's why hydrogen is placed in group 1. Similarly, it has got only K shell which is filled with 1 electron, and that's why it is placed in period 1. Similarly, the next element is helium. Its atomic number is 2. Right? So its K shell is completely filled. So this helium gas belongs to the group 18. Why it is placed here? Why helium is not placed in group 2? Because helium shows all the properties of noble gases. It has completely filled shells, right? And that's why position of helium is kept in group 18, in which all the elements which are placed here are all noble gases. Helium is a noble gas, and that's why it is placed in group 18. But its period is 1 because it has got only one shell, K shell, which is filled with electrons. Okay. The next element which is in the periodic table is lithium, atomic number 3. Okay. And this element is placed here because it shows similar properties to group 1 elements. In its electronic configuration of lithium, you can see atomic number is 3. So electronic configuration is 2, 1. That means it has 1 electron in its outermost orbit. And such elements which have got 1 electron in its outermost orbit are placed in group 1. Now you can see here hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. All these elements are placed in group 1. Why are they placed here? Because of their electronic configuration. You can see here the electronic configuration of lithium 2,1, sodium 281, potassium 2881, rubidium 281881. So there is similarity in their electronic configuration. All of them have got completely filled orbits, and plus 1 electron is present in their outermost orbit, and that's why all these elements valency is 1. So such elements who have got valency 1 are all placed in group 1. Okay, so that means all these elements have got same electronic configuration, and that's why they have similar chemical properties. Group 1 elements. Now let us talk about the group 2 elements. Beryllium, magnesium, calcium, strontium, barium, all these elements are of group 2. Why? Because they have got 2 electrons in their outermost orbits. The electrons which are present in the outermost orbit are called valence electron. As all these elements have 2 electrons in their valence shell, they all show similar chemical properties, and that's why they are all placed in group 2. Similarly, the other elements which we are going to discuss are group 13 elements. In these elements, boron, aluminum, gallium, all these elements have got 3 electrons in their outermost orbit, and that's why they are all placed in group 13. Similarly, group 14, all these elements are having 4 electrons in their outermost orbit, and that's why they belong to group 14. Students, you must be thinking why we are not putting them in group 3, 4 if they have valence electron 3 and 4. Why? Because these elements starting from group 3 to group 12, all these elements are transition elements, right? They are not the representative elements, and that's why their electronic configuration is different from these representative elements. The elements belonging to group 1, 2 and group 13, 14, 15, 16, 17, all these elements are called representative elements. But these elements from 3 to 12 are transition elements. They have got a separate different electronic configuration pattern, and that's why we will not include our elements in these transition elements. Okay, so the elements having 3 valence electrons in their outermost orbit are kept in group 13. Similarly, the elements having 4 electrons in their outermost orbit, valence electrons are 4, are kept in group 14. Similarly, group 15 will have all these elements having 5 electrons in their outermost orbit. Similarly, group 16, all these elements have got 6 electrons in their outermost orbit, so they belong to group 16. Similarly, these elements, these are all halogens. They have got 7 electrons in their outermost orbit, and that's why they are kept in group 17. So the students, you should know, if 7 valence electrons, then group 17. If 6 valence electrons, then group 16. Like that. Similarly, this is group 18, which belongs to, all of them are the noble gases. These elements are having all the completely filled shells, and that's why they are quite stable and they are not reactive at all. These are, all of them are called noble gases, and they are placed in a separate group called group 18. So in this way we see all these elements arrangement are arranged according to their valence electronic structure, valence electrons and electronic configuration. Right, now let us look here. These elements which are belonging to group period 1 are having only K shell. Okay, similarly group period 2, these elements like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, all these elements have got 2 shells, right? You can see here electronic configuration of these elements which are of period 2. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? So these elements belong to period 2. If you see their electronic configuration, you can clearly see that electrons are distributed only in K and L shell. That means they have got only 2 shells, K and L, and that's why all these elements are occupying period 2. They belong to period 2. If you think period 2, that means they have got 2 electronic shells. K and L shells are present in all these elements, and all the electrons are filled in only these shells. For example, lithium 3, electronic configuration is 2, 1. Similarly, beryllium 4, 2, 2. So only 2 shells are filled over here, and that's why all these elements belong to period 2, second period. Now let us talk about electronic configuration of period 3 elements. Okay, period 3, that means all these elements which are present in period 3, sodium, magnesium, aluminum, silicon, all these elements have got 3 shells filled with electrons. You can see here in the electronic configuration of period 3 elements, sodium, you can see sodium atomic number 11, electronic configuration 281. So 3 shells are filled with electrons. Similarly, magnesium atomic number 12, 282. This is electronic configuration in which 3 shells are filled with electrons. Likewise, all these elements have got 3 shells in them. That's why if they have 3 shells, they belong to period 3 or third period. Right? So students, if you should know atomic number of all these elements, then if you know the atomic number, we have to write down the electronic configuration. And from this electronic configuration, we can see what is the position of these elements in the periodic table. For example, sodium atomic number 11, electronic configuration 281. So if it has got 1 valence electron, that means this element belongs to group 1. Similarly, it has got 3 shells, and that's why what is the period of this element? Period 3. Correct? Similarly, if you think of phosphorus, atomic number 15, electronic configuration 285. So how many electrons in the valence shell? 5 electrons. So what is the group of this? Group 15. Okay. Now what is the period of this element? 1, 2, 3. 3 shells are filled. So what is the period of this element? Period 3. Like this. So there are many questions asked on this basis, that if the atomic number is given, you should know what is the position of the element in the periodic table. For example, the question is atomic number of chlorine is 17. what is its position in the periodic table. So if you know the atomic number, the first thing you do is to find out the electronic configuration. 17 electrons distributed as 2, 8, 7. Okay, now from this information, what do we know about it? It has got 7 valence electrons in its outermost shell. If it is 7, that means this element belongs to group 17. Okay, now period. Which period it belongs? 1, 2, 3. 3 shells are filled with electrons. So that's why the period is 3. Group 17, period 3. So such questions are asked in the exam. So based on this electronic configuration, you can find out the position of the element in the periodic table.